Hey, Mark, here's 59. Sure is dark. I don't know if I can make it any lighter. I'll just make it a little bit closer. Hopefully you can see it okay. All right, so this is about Marlin's breeding from exercise 13. I don't know if I need any stuff from that. In part A, it says, what is this equation of the least squares regression line for predicting the percent of males that return from the number of breeding pairs? Use the equation to predict something. All right, so in software output, the things that we need to be able to recognize, and I need to use a different highlighter because you won't see my green one, is this piece. That is your y-intercept, and this is how you get your slope. Okay, we're going to be using this. That's standard deviation. This is r squared, so we can get r from r squared. The rest of this stuff up here is not anything that you need right now. Some of it we'll never learn. Some of these other things like this, or the p-value especially, something we'll learn down the road. Don't worry about that right now. Okay, it says, what is the equation of the least squares regression line? So y hat, this is part A. Y hat is equal to a plus bx. Y hat is equal to, this is your A, the stuff that comes after the constant. You just have to get used to where things are with this software output. That's really all it is. So that's 266.07 minus, I almost put plus there, but notice that it is negative, 6.650x. What is the equation of least squares regression line? And there it is. I want to check in the book to make sure I'm leading you correctly down the right path. And that is correct, okay? And X stands for the number of breeding pairs, and Y stands for the other thing, the response for the percent of males that return the next year is what Y stands for. Okay, so then we also had to use the equation to predict the percent of return males after a season with 30 breeding pairs. So into Y hat, we have to put 266.07 minus 6.650 times 30. And I'm cheating. I'm going right to the answer book to figure that out. And in the answer book, when X is 30, Y hat equals 66.57. I want to double check that. Yep. Okay, good. All right, so there's part A. There's the answer to part A. This is the thing that you need to be able to do, is to get the equation of the regression line from the output. You should get the equation. I think I said this in the last video I sent you. The equation of the regression line given the means of the explanatory and response variable. And you should be able to find the equation of the regression line from data when you make two lists. I think in the last video, I said there's two ways you can be expected. You just asked me about the third way. I love the fact that you're working so hard to prepare for this. It says, what percent of the year-to-year variation in percent of returning males is accounted for by the straight line relationship with the number of breeding pairs the previous year? Is accounted for, can be explained by. Those are key phrases for the coefficient of determination, R squared. Okay, and so what I would recommend is that if you're not recognizing that, go back and look at the videos for R squared. Well, what is R squared in part B? It's this number right here, 74.6%. That's it. That's the answer, is 74.6%. I just noticed my face was in the way of that. Okay, so that's part B. Then it says, use the information in the figure to find the correlation R between percent of males return and number of breeding pairs. How do you know whether R is positive or negative? That's a very good question. Well, I know R squared is 74.6 or 0.746. That's R squared. If I take the square root of 0.746, I get 0.8634. 0.8, which is 0.864. So C, now hang on, C is 0.864. They asked this question, which they didn't have to do. They're being really sweet for us. How do you know whether it's positive or negative? That's really a nice thing for them to remind us about. Well, how do you tell? Well, go back and look at the slope. The slope was a negative, right? So that means our line looks like this. So that means that we have a negative correlation. And there it is. That's it. That's all you have to do is take the square root and make sure that you know that it is negative and that checks. Okay, and then part D says interpret the value of S in the setting. S is 7.76. I can't, it's kind of blurry on my output. It's this number right here. And I'm going to read to you what you should say as your interpretation for slope by looking at the answer. When using, here's the answer to D. When using the least squares regression line with X equal number of breeding pairs to predict Y equal percent returning, we will typically be off by 7.76%. We will typically be off. Use typically be off when you're describing standard deviation. Thanks for listening.